Hello, in this video we're going to go over functional groups. So in organic chemistry, many compounds have very similar arrangements of atoms, which have very common properties. So we end up kind of classifying these organic compounds based on these functional groups. So again, functional groups are unique reactive combinations of atoms that differentiate organic compounds into classes. So just some examples. You might have heard of alcohol before. Well, there's a whole class of compounds that have this OH group attached to a carbon chain, for example. And if you see that OH group, you can say, oh, it's an alcohol. Another example, if you have a carbon that has a double bond to an oxygen and then a bond to a hydrogen, this is called an aldehyde. Aldehydes tend to be compounds that smell really sweet or fruity. And then we have ethers. So if you see an oxygen in between two carbons, then that is called an ether. So except for alkanes, each functional group contains a multiple bond, so a double bond or a triple bond, or at least one oxygen or nitrogen atom. So let's look at all of these different functional groups. So we'll start with what are called hydrocarbons first. So they just contain carbons and hydrogens. So hydrocarbon. So we've already talked a little bit about alkanes. So alkanes are really not a functional group. They're just kind of the most basic organic compound. But we already saw that you can draw them with an expanded structural formula or a condensed structural formula. And here we're using the example of just two carbons bonded together with hydrogens making up for the other bonds. This would be called ethane. Now, what if we had two carbons that had a double bond between them? Well, that double bond would actually be considered a functional group, and that would be called an alkene. So again, you would have two carbons with a double bond between them. And if you have a triple bond, then it becomes an alkyne. So that's another functional group. If you have alternating double bonds in a six-membered ring, or just alternating double bonds, so let's say like down below we have a double bond, then a single bond, then a double bond, then a single bond, etc. That's what's called an aromatic compound. And the best example of this is a compound called benzene. So we'll talk more about this later, but benzene is a six-membered ring, and each corner of the ring is a carbon, and there are alternating single and double bonds around the ring. Okay, so that covers hydrocarbons, but what if we have oxygens or nitrogens in our molecule? So we already talked about alcohols. So you've got this OH group coming off of a carbon chain, for example. And if we look at this molecule here, that's called ethyl alcohol, or another name is ethanol. And that's what's in, for instance, gasoline or alcoholic beverages. So there's only two carbons and then an OH group there. We also saw earlier that if you have an oxygen between two carbons, that's referred to as an ether. Now, what if you have nitrogen in your molecule? Well, there are a class of compounds called amines, and that includes anything really with a nitrogen. All right. We also saw the example of aldehydes. So if you have a carbon with a double bond to oxygen and then a hydrogen on one side, that's an aldehyde. You can also have a situation where a carbon has a double bond to oxygen and is in between two carbon atoms. This would be called a ketone. And one really common example of a ketone is acetone, which is in nail polish remover. So acetone looks like that. Now, what if you have a carbon with a double bond to oxygen and it has an OH group on one side, like this example here? We call this a carboxylic acid group. And a really common example for a carboxylic acid is acetic acid, which is found in vinegar. And last but not least, we have a situation where you might have a carbon with a double bond to oxygen, and then on one side you have another oxygen that's then attached to a carbon group. This would be called an ester. So here we'll just kind of circle that. And then we have a similar situation here, but we've got a carbon with a double bond to oxygen, and then on one side we have an amine attached, so a nitrogen group. So this would be called an amide. So if you see a nitrogen group next to a carbon with a double bond to oxygen, instead of an amine, we call it an amide. All right, so I am going to ask you to memorize the functional groups because they are going to come up throughout the quarter, and we are going to talk about each of these in the upcoming chapters. So we'll kind of focus on different functional groups as we go forward. I did post some flashcards which can help with memorization, and these can be found under modules, study guides. All right. And if you have any questions about the functional groups, just let me know. In the next video, we're going to focus on hydrocarbons, so the functional groups that contain carbon and hydrogen only. So I will see you then.